Hi everyone, welcome back to Foundations of Math 11. This is part 2 of module 2. We are looking at data manipulations and the media. And this is actually a really important skill for you to have, the ability to look at graphs or charts that somebody gives you and be able to look at it rationally and critically and say, yeah, you know what? You're trying to mislead me here. You're trying to make this look like something it's not because the way you're manipulating your data. Okay, so before we move into the assignment and actually look at those graphs, we're going to look at some statistical terms. So a variable is a piece of data. A correlation is any statistical association between two or more variables or events. Causation indicates a relationship between two events where one event is affected by the other. In statistics, when the value of one event increases or decreases as a result of other events, it's said there's a causation. So I want to be really clear on the difference between correlation and causation. There's a saying that correlation does not imply causation. Did I say that right? Correlation does not imply causation. Things can be correlated without there being any cause related there. For example, you could look at the sales in a shop of ice cream and sunglasses. And there's probably a correlation there because when ice cream sales are going up, sunglass sales are probably going up too. But it's not like you're selling more sunglasses because you're selling more ice cream, right? One thing isn't causing the other. So that's a correlation, but there's no causation there. Now, if you looked at the outside temperature, there's probably a causation relationship there because the warmer weather is the reason that you're selling more ice cream. And the sunshine, which is probably causing the warmer weather, is what would be causing increased sales in sunglasses, okay? So you need to be really clear on the difference between correlation and causation. The last term is cherry picking data. And cherry picking is when a person makes a claim about something and then they just pick the data that supports it. They don't look at all the data, they just take the data that they like, okay? You can't, that's not fair. That's lying. And so that's called cherry picking data. All right? Okay, let's look at this example. What type of graph is it? This is a bar graph. Oops, my R didn't show. What's it trying to show? The graph is trying to show the average house price in 1998 and 1999. The graph is misleading. Explain why. Well, for one thing, where? This doesn't tell us much about anything. Where could you get a house for that price? Oh, maybe in 99, 98. No houses for that price. It's not around here. And it's also the data is only over 2 years. Oops, only over 2 years. Impossible to see a trend. And I know you already have this written on your notes, so that's why I'm not worrying about writing it neatly. Why might the creator of this graph have made a misleading graph? Do you think they made a mistake or do they have a motive? Well, they might be. I'm just going to read it. They might be trying to make it look like prices are staying constant because there's not much difference over those 2 years. And maybe if you looked at it over 10 years, you would see a trend or you would not see a trend. I don't know. But just showing this data it's not very useful, and it's, yeah, okay. So you're going to go on and do the practice questions. And you need to check them in with your teacher, it says. They've been created to misrepresent information in various ways. Answer the questions following each graph and then check all your answers with your teacher. I think that that's probably because there's lots of things you could point out that are misleading on these drawings, and your teacher just wants to see how you're thinking about that. Okay, so off you go and come on back for the next section. Okay, let's take a look at section D on misleading statistics. What is a misleading statistic? It's simply the misuse, whether it's purposeful or not, of numerical data or numbers. It's the misuse of numbers. The results provide misleading information to the receiver, who then believes something's wrong if they don't notice the error, don't have the full picture. Okay? And this is done all the time. All right, example. You're more likely to be hospitalized with an injury from a high-speed collision if you're wearing a seatbelt. So this may be actually true, but people could interpret this as seatbelts are bad, and it's misleading because if you're not wearing a seatbelt, you're more likely to die in a high-speed collision. So if you die, you're not going to be hospitalized. So there's an example of using some number which is it being presented in a way that makes you think something other than what the data maybe really shows. Okay, somebody's doing that for a purpose. They've got a mission. Okay, all right, there are a couple pages of examples, and that is the end of Module 2. Have a great day.